All right, let's pick up where we left off. We were talking about divisibility rules, and we learned that if it's an even number, it will be divisible by 2. So that any number that ends in a 0, a 2, a 4, a 6, or an 8 is an even number. So it will be divided evenly by 2. With divisibility rule of 3, we have to add the sum of the digits, and if the sum is divisible by 3, then the whole number is divisible by 3. Divisible by 4, we look at the last 2 digits. If it's double 0, like 100, 200, 300, 1,000, a million, then it's automatically divisible by 4. And then another way we do it is we look at the last 2 digits and say if 32 was the last 2 digits, then we know 4 goes into it. But if it was 15, the last 2 digits, we know 4 won't divide into the number. For 5, we're looking for 5s or zeros at the end. Anytime a number that ends in a 5 or a 0, it's divisible by 5. For 6, remember it has 2 rules and we have to follow both rules. It must be divisible by 2, which means it has to be an even number, and it must be divisible by 3. All right, so 6 has 2 rules and we have to follow both of them. We have divisible by 9. Again, like 3, we added the sums and if the digits, and if the sum was divisible by 3, it was 3. So 9 is the same thing, except that the sum has to be divisible by 9. And divisible by 10, it can only end in a 0. It must end in a 0 for it to be divisible by 10. Now, we left off with some problems. We were going up here through this chart, and we did 120 together, and we knew it was an even number. We added the sums. 1 plus 2 is 3, so 3 goes into it. The last 2 digits is 20. 4 goes into 20. It ended in a 5 or a 0, so it was divisible by 5. It's divisible by both 2 and 3, so 6 is automatic. If we added the sums, again, we got the digits. We had 3. 9 doesn't go into 3, so we left that box blank. It does end in a 0, so we knew it was divisible by 10. Now, I left off with you with 96 and 378 to do on your own. Remember, we did 611 together, but it's not an even number. It's not divisible by 3. The 4 doesn't go into 11, the last 2 digits. It doesn't end in a 5 or a 0. It's not divisible by 2 or 3, so it can't be divisible by 6. The digits do not add to a number that 9 is divisible, and it doesn't end in 0. So the whole blank, all boxes were left blank because it's not divisible by any of those evenly. Now I gave you the last 10 of 96 and 378. I did say they were both even numbers, and because they're even numbers, they will be divisible by 2. So let's start with 2. If we add 9 and 6, we get 15, and 3 does go into 15, so it's divisible by 3. Does 4 go into 96? Well, sometimes we're going to have to just kind of take the last 2 digits and do, let's see, 96 divided by 4. 4 can go into 9 2 times. That gives me 8. Then I subtract. I get 1. I get 16, and 4 does go into 16. That would give me 24. So, yes, it's divisible by 4. Now, it doesn't end in a 5 or a 0, so 5 is out. It doesn't divide by 5. But it is divisible by 2 and 3, so that means 6 is automatic. We said the sum of the digits was 15. 9 doesn't go into 15, so 9 is out. It doesn't end in a 0, so 10 is out. If you got those correct, you would have had 96 divisible by 2, 3, 4, and 6. All right, let's go to 378. Again, 378 is an even number, so it's divisible by 2. If we add the digits, we get 18. 3 plus 7 plus 8 gives us 18. 3 goes into 18, so that works. Again, does 4 go into 78? Well, you could figure it out by going 78 divided by 4. 4 goes into 7 once. That gives you 38. 4 doesn't go into 38, so 4 is out. It doesn't end in a 5 or a 0, so 5 is out. However, 6 is a winner because it's divisible by 2 and 3. Now 9, if we added the digits again, we got 18. Well, 9 goes into 18, so 9 is a winner, and it doesn't end in a 0. So look at it as thinking of a factoring is like a factory. What goes into the product? What goes into the machine? What can make the machine work? All right, and when I think of multiples, I think of the word multiply. So we're going to get into factoring today, and I hope you enjoy this lesson. Again, I appreciate you tuning in today. Please like, share, and subscribe, and we'll get right into factoring. All right, so I wrote the definitions up here. I apologize for the glare on the board. The lights are a little bit weird this morning. Okay, so we have factoring. Again, if we can remember that factoring, it's the factory, all right? It goes into the number. It will go into the number, dividing it evenly. It will have no remainder. So a factor is something that goes into a number evenly. It makes the machine work. All right, then you have multiples, and if we can remember multiples means multiply, then we'll keep those numbers separate. Again, you have one that goes into the machine, and then you have multiply. So I wrote some numbers up here. I wrote a 6 up here. All right, we start with the factor pairs. These are a group of numbers that when multiplied together, the product equals 6, or the number that's given. All right, so we started with 6. We will always start with 1 times the number. So 1 times 6, that is our first factor pair. All right, then if we go, 6 is an even number, so we know 2 times 3, that is another factor pair. Does any other two numbers multiplied together equal 6? Well, no, so this time this is done. Our factor pairs are 1 times 6, 2 times 3. Again, remember a pair is 2. All right, so you have a pair of legs, you have 2 legs. I'm going to throw this in there a little bit. So science, we talk about an insect having 3 pairs of legs. All right, that's 3 times 2, and we know insects have 6 legs. So it's good to remember what the word pair means. All right, a pair is 2. All right, so our pairs are 1 times 6 and 2 times 3. Now our individual factors are 1, 2, 3, and 6. And I write them out in numerical order. When you're doing words and you put them in alphabetical order, you're putting them A to Z. So when we're doing numerical order, we start with 1 and then we go to the largest number. All right, so our factor pairs again was 1 times 6 and 2 times 3. Our individual factors are 1, 2, 3, and 6. All right, let's try 9. What do we always start with? We always start with 1 times the number. All right, well, 9 isn't an even number, so we know 2 doesn't work. But 3 times 3 is 9, so we write 3 times 3. Is there any other pairs multiplied together that would equal 9? No. So we have factored 9 out with our pairs. 1 times 9, 3 times 3. Now we write our individual factors in numerical order. And notice it's going to go down and then up. All right? So we have 1, 3, and 9. Notice I did not need to write 3 and 3. We already have 3. It's the same. We don't need to write the same digit. All right, let's try 12. What do we start with? That's right, 1 times 12 is our first factor pair. 12 is an even number, so that's 2 times 6. 3 also goes into 12. 3 times 4. Do we have any other pairs that will factor into 12? That goes into the machine. 12 is our machine. We're putting things into the machine, all right, to make that machine work. All right, so we have factored this out in our pairs. We have 1 times 12, 2 times 6, and 3 times 4. Our individual factors, then it's going to be down. 1, 2, 3. Now I go up. Whoops, that's an ugly 3. 3, 4, 6, 12. And those would be our individual factors of 12. Now, if we want to compare numbers with a common factor, common simply means the same. We could use these 3 that we've done on the board. We see that 1 is common in all of them. All right, 1 is common. All of them have a 1. Now, do they all have a 2? We have a 2 here and a 2 here in 12, but we do not have a 2 in 9. So 2, if we were comparing all 3 numbers, would not be a common factor. But here, what about 3, 3, and 3? So 3, 3, and 3. Those are all common. They are in all 3 numbers. All right, now if I wanted to say the greatest common factor, well, 1 or 3, which one's greater? Yeah, 3. You want 3 cookies, not just 1. So our greatest common factor would be 3. Again, we're practicing on what things that go into the machine. So let's do 2 more. Let's put 2 more numbers up here and work on our factor pairs, and then see if we can compare them. All right, let's do 18 and go ahead and do 24. Okay, so what equals 18? What do we start with? That's right, 1 times the number, so 1 times 18 is our first factor pair. 18 is even, so that would be 2 times 9. If we added 8 and 1, we get 9, so we know 3 goes into it. So 3 times 6. Does anything else go into 18? No, we have factored 18 out. So let's write, these are our factor pairs. We have 3 pairs. But now let's write our individual factors out. Let's go again. It's down and then up to keep them in numerical order. 1, 2, 3, 6, 9, 18. All right, let's factor out 24. I think you can do it. Actually, I know you can do it. So let's start with 1 times 24. All right. Normally, you'll see your pairs in parentheses. That's why I'm just adding the parentheses. All right. So then, what's an even number? So we have 2 times 12. Does 3 go into 24? Yes, it does. You're right. 3 times 8. Does 4 go into 24? Yes, it does. 4 times 6. Does anything else go into it? No, I think we factored it all out. All right, so our factor pairs, again, to write them in numerical order, we're going to go down and then up. So we have 1, 2, 3, 4, 6, 8, 12, 24. Now, again, if I want to figure out what's the numbers that are common, I simply go through. We have a 1 that's common. We have a 2 that's common. We have a 3 that's common. We have 6 and 6 that's common. But then we do not have any more 9s or 18s. So we have a common of 1, 2, 3, 6. These are all common. Of 1, 2, 3, and 6, which would be the greatest common factor? Which one is the greatest number that they have in common? Very good. 6. And you'll see that written as GCF, greatest common factor. Next lesson, we're going to do multiples. And again, we'll remember that multiples means multiplied. The word multiply is in the word multiples. So our 2 things that we're doing this lesson and next, factoring. Factoring, putting the numbers into the factory. All right, multiples, multiplying. See you next time.